Okay. Hello everyone. Let me just put the volume a bit down. How's everybody doing? Just setting up the last things. I think we are fine. Okay, so all right, so I guess we can start, and let me check that all the views are there. This is done, this is there, and this is there. Yay! Okay. So let's get started, because today it's gonna be quick and easy. I'm going to develop a person detector and a face detection method and integrate that with what we already have, which is the what we called Argo last time. That's the I will share the repository immediately after this. So this is what I mean. If you go to Amatix, github.com/AmatixArgo, I will report the link later. And also, this GitHub repo is currently private, so I will open it. We'll make it public, so whoever wants to contribute, of course, they can take the code, they can read and make it better. So I called it Argo last time because Argo is the Greek, in the Greek mythology, is the monster with I don't know if it's a monster, but it was a guy with 100 eyes. And so since this is gonna be a surveillance camera system, you get the math. So another thing that I want to make sure it's there, if I go to the browser again, so there will be, I will keep updating this list here. We don't have a person detector, for example. It's already part of the object detection method that we added last time. And before doing face recognition, we are going to add face detection. So face detection is not face recognition. With face detection, you essentially can detect that in a frame there is a face or many faces, but recognizing a face is a different story, because you need to translate that image usually into an embedding, which is a relatively high dimensional vector that represents that particular face. So first of all, you want to cut the face, in a bounding box in the frame, and then you want to take this face and convert it into a vector, and then you can do some matching of faces that you have in a dictionary or in a database, and say, okay, this face that that comes from the webcam, for example, is indeed similar to this other face that I have on my database. That's the idea. And of course, the more accurate you are with detecting the face, the better chances you have to run a recognition algorithm successfully. So, well, let's get started. I move to the code. I hope this is good enough. Like the size of the font should be enough, I hope. Let me make a test here. Test from me. Yeah, it seems to be there. Cool. Okay, so let's recap a bit from last time. We did something, we did some code refactoring. So we have the detect SSD objects, which is the module, the Python module that does the actual object recognition, object detection. And so there is a number of objects that we can recognize and detect, in fact, which is airplane, bicycle, bird, and you see them here. And it was pretty successful because it's relatively fast, considering that we are not optimizing yet. So we are running everything in Python still, so it's pretty decent. If you want to try this out, Python main, that should give you, yeah, I bring this in. So I have another camera there, and the label that is assigned here is indeed person, and 99.9 something is the confidence that indeed I am a person. There is a chair here, and this is quite interesting because the model has been trained to recognize a chair where there are persons. What is that, a bottle? It's not, it's my hand. Anyway, so there are some nice features and some nice bugs that I found by playing a bit with this. So a chair, you cannot see the chair, right? It's right behind me, of course, but the model assumes that there is a chair behind a person. So that's why it's quite interesting. And it's very, the confidence is very high. It's 92, 93, 92%. It's a lot. So, if I show the chair now, that's weird, because it's not recognized as a chair. So by showing the chair, the model doesn't get it, which is very, very weird. And by covering the chair, probably the model thinks that there must be a chair because there is a person, and without even looking at the chair, assumes there is one. Okay. Another thing I found is that, I could make a chair with my hand. It's quite weird, but anyway. So, well, long story short, this model is not really, super accurate, but it's fine for what we are doing now. It's okay. Okay. So we have this. We have the detect objects that takes the frame and does a bunch of stuff. Then that we saw last time. So it uses the OpenCV2 to get the frame and to transform the frame in a way that the model understands what it is, and then it continues by running the running the neural network, calling the forward method after I set the input, which is the frame itself. I get my detections, and then last time we extracted these detections, and we said, okay, whatever you find in the frame, you must have at least a confidence of 0.7, 70% to actually to draw, first of all, a rectangle, which is the bounding box around that object, and then draw it on the frame itself, right? And then we return results, which is the dictionary of detections, together with the type of the object that has been recognized, if it's a chair, if it's a dining table, a car, a person, etc. And of course the confidence that has to be, for obvious reasons, higher than 0.7, and then the bounding box, which is the rectangle that is right around the detected object, okay? And then we return two things, result and image. Image is not this frame that is the input, because otherwise we go and overwrite it, which I don't like. But its image is a copy of this frame, which is an array, by the way. And then on top of that image, that is a local copy, we essentially draw the rectangle and we add the label, and we add the confidence and all the things that you see, the augmentation, the annotation on the image. So in this way, we don't break the frame, we keep it like that, original image, you never change it. I also created a main in the module that essentially connects to the video device. In my case, is 0, which is that camera there. And then we start reading frames, and we pass each frame to the function detect objects. Okay. And last but not least, I created a new module, which is main, which is the actual module that we. Hey, ciao Roberto. Hello. So is the last. I don't know. I see some chats from LinkedIn. Okay. So I cannot reply. I can only reply from the Twitch chat. So if anybody is on another channel and want to interact, and you want me to interact with you, unfortunately that's only Twitch that I can use as a chat. But thank you so much for following, and of course I hope you stay. So another thing that we have, I've made last time, is the main module that is exactly, what we are going to expand today. Yes, that's true. I'm also live on YouTube, LinkedIn, Twitch, and that's it. Maybe Facebook, could it be? I don't know. I use one of these restreaming platforms where one stream is actually on multiple channels. I can do that as long as I'm not an affiliate of Twitch. As soon as I become, hopefully, more followed on Twitch, probably Twitch is going to deny the restreaming. So let's do it as long as we can. All right. So in the same light, in the same style of last time, I want to enhance this particular module, which is the main, and essentially create different modules here in which we implement new functionality. So for example, today we are going to implement the face detection, right? So the face detection, I want to add it as an external module, separate module, like SSD object, that is specialized in recognizing, in detecting faces and then recognizing them. And then we're gonna add things from there, right? So we're gonna have something like that. Detect face. Let's say we pass the image as well. Something like that. Of course, I'm just writing some. It's not pseudocode, but it's like bullshit code. It's gonna be much cleaner in a minute, but that's what I want to do. So to start with, let's start with creating a new module like this one, but specializing in detecting faces. Okay. Oh, for detecting a face, I'm going to use a library that is MediaPipe, that is optimized for mobile, and that's freaking fast, like seriously fast. It uses BlazeNet, something like that. There is a network that has been optimized for mobile, and it's really, really fast. Now, I'm okay with that because it's not 100% accurate, but that's fine because, consider that in 1 second you have, 15, if you're good enough, if 10 to 15 frames per second, right? So you have 10 frames in a second. So in 1 second, you have a lot of chances to detect a face. If you don't detect the face in the first frame, you have a good chance for doing that in the next frame and the next frame, and up to 10, you're still in the 1 second time frame. So supposedly the person hasn't moved that much unless they're going freaking fast in your office, and then you would see just a shadow probably. But that's a different problem. So yeah, let's do that. So detect face, we create this new file, I would call it the same, detect face, let's say .py. So again, here we need CV2, we need, as I said, MediaPipe is something that is quite an interesting library. Let me see if I can share, where is it? I don't find it. Anyway, MediaPipe, face detection, there you go. Maybe it's, yes. So it's this one. It will do that. So, Blaze Face, that's the model it's based on. Okay, cool. So we probably need NumPy at some point. And as I said, we take this main, we take this, and we say this def detect face. I want to use the same like that. Okay. So you use the same signature, okay, as that one. So you pass the frame, and essentially, oops, what did I do? Okay, and essentially you're saying, okay, now, let's have a similar signature so that from main, so if we put pass here from now, from main we can say here from detect face import detect face, it's the name of the function, and of course this will actually work. Now let's not overwrite stuff, detections. So I would say detections objs objects maybe, and detection face annotated. This will be overwritten. Okay, so that's what I want to do. Now we still don't do anything because detect face does nothing, but we'll get there. So there is a way that so there is a we need to load the model. So I checked from the documentation of MediaPipe, MediaPipe face detection, you need to load the module. It's a global variable. So MediaPipe MP solutions, I'm reading from the doc, face detection, that's the model, Blaze face model that is pre-trained and just loaded. And then there are also some drawing utilities, which I call drawing mp.solutions.drawing utilities, utils, I think. So these two boys here are, just global things. We pass the frame. We can remove this pass here. So here frame.flags writable equal false. So this speeds up stuff. When something is flagged as not writable, indeed the frame from detect face perspection has to be read-only. Sometimes I have to go on Twitch and see who's there. Okay, so I just want to make sure that the chat that I have here is indeed up to date. Okay, it is. Nice. So we go there, we do frame, we set the color RGB. So we need from OpenCV will grab frames in BGR, and we need RGB. Okay, so cv2.cvtcolor take frame cv2.color BGR GR2 RGB. Okay. Okay, so to this function, I also want to pass the model that I'm going to use, okay? And then we can add other parameters later, but essentially what we want is to do model process, and you pass the frame, and that's the signature. We put everything under results, okay? So let's start also, at the same time, I would like to have some sort of main to test things out, okay, without importing stuff from this main. All right. So I think it's like last time. We can take this, so we can use this as a test. It's not the right way of doing things, I should say, but it's okay for now. We will have time to write our tests. Okay, and so we can just copy this. Okay. Okay. So what do we do? Here we have, we call the detect phase. We pass the image and the model. What is the model? The model is phase detection. That is MP phase detection. But according to the documentation, the way we do this is this. It's with the with construct. So with MP phase detection dot phase detection, and you can say which model you want. What does it want? It wants model selection. 1 stands for long range, and the confidence. So mean detection confidence 0.5. We can increase that later. And we call it phase detection, okay, or phase detection model or whatever. So this goes all in. There you go. Well, this has to return detections like that. Okay. Cool. So, I think that's pretty good. Let's copy this back. Well, this in fact goes. Sometimes I hear weird noises because it's my cat that goes around. freaks me out. So here there should be also an annotated image, okay, that we will print, well, we will show together with, you know, right after the detection. Okay, so I guess this wants to return results, and we can do the same as before, what we did here. Okay. Oh, sorry. Here. And then we will add annotations. Okay, we do it later. So this will return results and the annotated image that is returned here, and then it should be fine. So this will not do anything except for transforming copying the image locally and simply transforming that. I would, at this point, I would do this into this. I think I can do that. I'm not sure. Indeed, I can't. That's not an array. What happens if I do this? Ooh. It doesn't transform to BGR RGB, right? Okay. BGR to RGB. Yeah, that's correct. I think that's normal. Can I return frame here 1 sec? Woo! All right. What the hell? All right. So apparently, if I copy this frame, it doesn't like that I set these flags as writable equal false. Okay, well, let's proceed with the prediction. Okay. Let me see. So we need to take, we're passing this face detection model to this model here, and then we process, we call the dot process of face detection, and that's correct, and we get the results. So eventually I can print detections here. I should find something. And indeed I do. So I'm printing stuff. Okay. And it's media pipe data structure. Okay. Okay. So now what I want to do here is extract from these results and look inside. So I'm a bit annoyed by this guy. Should work because I want to set the flags. Detect face line 10. NumPy multi-array object has no attribute writable. Really? I'm passing this image, which is just an array. Okay. Well, whatever. So let's unpack these results. Okay. If results dot detections, there is a documentation of media pipe that I'm reading. So for detection in results detections, so for, there can be multiple detections depending on the how many faces there are in the frame. So I would also add another parameters here because we don't want to draw all the time. So we want to let the user draw. Okay, so this is a Boolean. Okay. Actually, let's say it's true by default, and if you want to switch it off, you just have to do it. So if draw, okay, it's true. We use mp drawing dot draw detection. You pass me the frame and the detection, so you can draw that. You can annotate the image. In fact, the frame should be this. This doesn't go anyway. Okay. And now I want to unpack everything in a dictionary, detections, and say, okay, let me see if I can read this. There you go. So every detection has these keys. Okay, so we want to unpack this stuff into our data structure, which is this detection dictionary here. So here I'm doing, let's say, score. It's gonna be what? It's gonna be detection dot score. Then we have label ID, So these are not really dictionaries, these are objects. So there is a class behind that. That's fine. Then we can create another one, detection location data. So when there is a detection, the MediaPipe library will detect 1, 2, 3, 4, 5, 6 key points, which are, I guess, the nose, the eyes, and on the lips there is something there. And these are coordinates that refer to that particular face. Again, these are not good to be used as a face recognition model. they're not accurate. You usually have hundreds dimensions, that is the embedding of the face, to have an actual, vector that represents that face. Otherwise you can game this system pretty easily, because an image with a relative distance of the eyes and the nose and the mouth similar to another one, just because they are more or less in the same normalized position, that would match, which is clearly wrong. So yeah, you don't want to do that. So once we have these face key points, we can add, hey Alfred, to detections, location data, key points equal face. Hey you. Okay. So now we should see something that makes much more sense. Yay. Okay. So as you can see, we have, for each detection, we have the score, the label ID, the location data, that is the bounding box, where it is, till here, and each of the 6 key points XY coordinates. Good. Okay. Well, we have that. So here we want to draw. It's weird that it doesn't draw anything. So I want to create these additional settings we might need. Because I don't like to hard code stuff. So we want to return image. There you go. So these are the annotations that I was mentioning. It's the 6 key points, 1, 2, 3, 4, 5, and 6. It's pretty fast, right? So this blue, like the Smurfits, is because the BGR to our RGB isn't working. I have no clue why. Let's try to fix that. So it's probably because it doesn't like me to copy stuff. No, still. Okay, I forgot this. So the model wants RGB, but then we need to return to BGR. After we have run this model, whoa. So now it should work. Yes. Ooh. I try to break this algorithm sometimes. Okay, so this is working. All right. So this is done. I still don't understand why it doesn't allow me. Anyway, it's not that important. Okay. Okay, so I'm gonna create now another class in which we're going to start putting, we're going to put all these, you know, models. I'm thinking. So in fact, I want to take this. I want to bring this into our main. Which obviously cannot happen. Have to remove it from here. So let me do this. But MP drawing, oh shit, I need. Okay, I have to think about it. Let's do this. Let's do the body pose detection for the person, and then we think to go back here. I want to create another class that will integrate all different models to detect objects, to detect face, to detect body pose, to detect hand gesture, to detect all the things. And you know, you can have this other class, I don't know, like we call it monitor, that will call the models that it requires to provide that functionality. But we'll think about that later. I would go still with MediaPipe and do the detect pose. So we can take this new file. Let's call it body pose. Okay. This will have the same. Well, in fact, hey Alfred, what's up? Ciao. Come here. Come on, Fridge. There you go. He's so cute. All right, so let's do this MediaPipe thing. So I guess we have the same drawings. And the model is gonna be MediaPipe, let's call it pose, mp.solutions.pose. That's the model. I don't recall, let me see. Media pipe. So we want to do that. I mean, not that, just the detection. I cannot do that. Oh, blaze pose, okay. So blaze face, blaze pose, okay. It's the same family of models. All right, cool, let's do that. So I copy and paste here. There are 33 pose landmarks that are detected. Hey, Kutniemi, how are you doing? Yes, I do. I just code and have some notes, and I Google, and we build things together. It's pretty cool. So far we did a face detector and a person detector, among other things. Let me quickly show you what we got. Yeah, of course. There you go. So we can detect the face. We can draw a bounding box around it, and also have the the landmarks on the face. So you can use to do other things. For example, you can eventually place a face mesh, or you can replace your face, or manipulate the eyes or the nose, stuff like that. Okay, cool. Let me continue on the body pose. Now we want to detect 33 pose landmarks. No, actually, I'm building this for myself. And yes, to use it in action, to use it in production. So this is a full series of, from the model, from the predictive models to the productization of this in a framework. So there will be a database, there will be analytics on top of these detections, so we can have more and more powerful and smart features of a surveillance system. So likewise here, I want to have, yeah, it's cool. Okay, let's use the same signature. In this case, it's gonna be detect pose, frame, model, draw equal true. In fact, I'm also going to change this one. If we want to draw, we want to use these two things here. And let's put a to-do. I don't want to break the flow now. Decide to annotate and return. Okay, we'll do that later. So at this point we need to I would start from the main. So as always, we put this here, and then we do basically all this. We take the video device, and this time we have mp pose, mp underscore pose. This is gonna be so from the documentation of MediaPipe, this is different. It doesn't use the with approach, which is better in my opinion. Okay, so we open, let's do this. Detect pose. Actually, just for debug for now. So this should not, at least should not break. Oh yeah. What is none? Oh, but I cannot print none. Okay. I'm trying to break Python. So let's implement something and then we'll see. Detect pose takes a frame, takes a model. So it's very similar to what we already do here. I would do exactly the same. Okay. And detections is this, so we can return an image. Okay, it's a test. We are not doing anything here. Okay, that's fine. I'm a smartphone. It works. So yeah, we have to do this back and then it should be fine. Okay, and in between we have the model. So it's the same here. Okay, same as before, same as this. So now there are 33 poses that MediaPipe is recognizing. Well, it has been trained to recognize. Let me, these are like the nose, left eye, right eye, left ear, right ear, the knees, the hip, pretty much all the joints of your body. Okay? And these are encoded in, normalized coordinates. So let's try to unpack that, because now, we should have we should have something here. Instead of, let's do this. We ignore detection because I want to unpack whatever is in here. Yes, so you see there is something in here. So we are printing this guy, the result of the prediction. So here I want to unpack so that we can return the unpacked version of our detections, and what is in there is results 0, 1, 2, depends on there are 33 of these things. Okay, so the problem is, let's do this. I'm not sure it will print anything because it's an object. Yes. So it prints the visibility X, Y, Z. Oh, okay. There are 33 for each frame. There are 33 of these things, and indeed there are some that are not visible. So all the body landmarks are calculated on the single frame. Of course, not all of them are visible. For example, my knees, you cannot see my knees. So visibility is going to be 0.000 something, probably is one of these ones, right? Now, there is, if you go to the MediaPipe library, you will find what is the index that you have here. It can be 0, 1, 2, etc. So we can do something very stupid, which is for I in range 33, you do this, okay? Now, and this is also there you go. Okay, so these are all the body the body landmarks that have been detected. So what I want to do now is, instead of printing this stuff, we say detections at I equal that guy. And we return detections. Right? I guess music is off because I need to play it. Oh, I had an interesting one. Actually, this is cool. Okay. If anyone has suggestions about music, always welcome. All right, we are almost there, because now I'm gonna do one thing like before. If draw, we annotate the image. Okay, and so we say MP drawing, draw landmarks image results pulse landmarks which is the things that we have printed before. Um, and the post connections. So these are, you will see it later, you will see the joints are connected by lines, like a skeleton. You will see in a minute. This is super cool. And finally, we have the landmark drawing spec. I'm an idiot. Oh wow. Okay, so this is because sometime we might not have one or more of these landmarks. So for each of these, I would put this behind a try except, and if there is nothing, I just pass. Okay, this will slow down a bit, so it's not a final solution to that. Okay, try except are the worst thing you can do. We'll find other ways later. So I would put this in settings. I also don't like to have numbers. Max body pose landmarks 33. Okay. And so freaking fast, isn't it? You. Okay. Okay, so that works. So now we have face, we have body, we have person, we have cat, we have other objects, up to 20 different objects, but like cars, trains, we don't really need that for, you know, for an office, but they're there. Okay, so we can stop printing this stuff because this, you know, it's fast, but still it can be faster. So we can get rid of this detection, this print here. Let me just check. Yeah, much quieter. Okay, so there is no you know, there is no hand. The next thing is we're gonna do is like the hand gesture. Okay, so only thing we do now is, you know, left hand, right hand, different color, left eye, right eye, different color. I can mix my hand, still okay. Oh shit. Okay, whatever. That's true, Kutniemi. Tech is scary. It's also nice. I mean, there are a lot of good things that tech can do. Depends how you use it. Cool. So let's move on to, so we can get rid of this SSD, we can put this back there, and we have face, we have body. I would do also the hand gesture. So hand gesture is another model that is way more refined and, you know, specifically trained for recognizing fingertips, like fingers positions. So now in the body pose, the hand is just 3 points, right? That probably tells the system the coordinate where the hand is, the rotation of the hand, and that's it. But if I'm doing stuff like this, or stuff like this, or stuff like this, or stuff like this, or stuff like this, you know, I would like to have a model that can actually count, for example, how many fingers I'm raising, or if I'm doing this, it can interpret my hand gesture as, I don't know, okay, as get out, or, you know, whatever. And why is that? Is because in a smart surveillance system, I want to have something that is, you know, smart. So for example, I might be in a situation in which, think about this, I have a thief next door, or an intruder, or whatever. I cannot speak, and I want to instruct my smart surveillance system that there is someone in the building, but I cannot speak, I cannot make noise. So by giving some special gesture, I don't know, one can encode whatever, you can, you know, give commands to the surveillance system to, for example, call 911 or whatever other emergency number you have, right? Depending on the country. So that's the idea of why one wants to have an hand gesture system. Hand gesture is cool because, you know, you will see now how do we manage that, but it's very useful in many situations where it is not allowed it or not possible to communicate something, you know, with voice or with vocal commands. So the structure is very similar. Well, first of all, let me save this work. Git status, git add detect body pose and detect face. This is the work of today. Exactly. You can even use with smart lighting. So you have a camera and you can switch on and off lights, or I don't know, doing on and off. How would you do on and off? Or on and off? Yeah, absolutely. Yeah, you can customize these things. I mean, it really depends on what you're doing. Like, are you doing something for security? Are you doing something for, let's say, an hospital, for healthcare? You know, every sector have its own language. So git commit session 2 face detector and body pose detector, git push. Okay, now I feel safe when I save my work. Actually, there is another thing that I wanted to add, which is the models that I'm using, except for MediaPipe. Last time we used these other models here, which is MobileNet SSD, single shot detection. They're not that big, you know. 23 megabyte, 13, yeah, they can still go on Git. Is bulk release common where you live? Like, is there actual thread? No, to be honest with you, I live in Belgium, and it's a pretty safe area. I mean, it's a pretty safe country, more or less everywhere. Of course, there are, you know, places you would feel less safe as everywhere else in the world. But yeah, it's a pretty safe country. But I do things for, you know, against bad people. Let me put it like that. Yeah. So let's add these models too. It's gonna be a bit bigger, but a bit big, but it's like 50 megabytes. That's it. So, okay, let's put everything in main for now, and then we'll start having new branches. Okay. There you go. Yeah. All right. Okay, so let's see. What else can we do? The hand gesture I was saying. Yep. Okay, let's do the hand gesture, and then we'll see how we can integrate all these things. Okay, Git is done. So for the hand gesture, I would create exactly the same structure as before. So let's create this new file. We call it detect hands. And this guy. I would say that it's very similar, so let's just copy this. Just broke my knee. Fuck. Okay. Oh, okay. MediaPipe doesn't do, it uses a model for a lot of stuff, for pose, face mesh, face tessellation, left hand, right hand. Damn. Okay. So we have to use a holistic model. Then let's rename this holistic. Makes more sense. And you know, I can even say, since this is gonna have, you know, you can choose to use this model for a bunch of things. Like, in fact, there are several things that it can detect. It can detect phase tessellation, let's make it a bool. Oh, right. Okay. But start with the hands. So in here we have everything. Okay, so if let's do this. Okay. Oh. We have to print. So this will print some object. We will not see what it is exactly. Okay. So we need to unpack all these things. P. So it's results pose landmarks landmark MP holistic pose landmark dot nose, for example. So it's something like that. Dot x. I want to print this. So for example, nose x equal I have no clue where it is. Yay! Okay. So we have to unpack from MP holistic, pose landmark, nose, and all the others. Let me print this. Okay. Pose landmark is an enum. How can I print all the keys of the enum? MP holistic. Let me go on GitHub, 1 second. Media 5. MP holistic. It's under Python solutions. Holistic. Results pose landmark. No, MP holistic pose landmark. This guy. Python solution pose. Hey Gaetan, hi. Thank you. Yes, this will be available on Twitch for the next 7-8 days, I think. And also the repository will be released as open source starting from next week. So this is MediaPipe Python solution pose post landmarks solution pose. So it's here. There you go. These guys, I found them. So yes, these are the 33 pose landmarks that we need. So let's do this. Let's document this. Okay. Wow. There you go. So for each, so you know what I'm gonna do? I'm gonna do this. Well, first of all, let's see if this works, okay? Let's see if it detects something to start with. And so I want to draw left hand, right hand. So with this, we should draw, let me see if it's true. So yes. So with this code, at least we should be detecting what our fingers are doing. Who's ready to see the fingers moving? Okay. Let's see if this works. 1 second. Okay, so let's start it. I find this annoying. This is rename into holistic. All right. So Python detects holistic. You. There you go, guys. Hello. It's freaking fast. It's super fast. Isn't it? So there are only for the hands, I don't know how many detected landmarks do we have. I'm gonna check that. But that's not all, because we can do a lot more than this. So hand gesture is here. I can count 1, 2. I can train a machine learning model to consider this, fingers position and landmarks and count or interpret my hands with whatever command. So we might think of having even a lookup table with the hashes of where more or less the position of the combination of my fingers would be, and just pick the command that is most similar to the hash, right? There are many ideas that we can implement, but for now I really expected to find something on my hand, but it's not. Okay, so this works. Okay, so we are trying to print here. So when I have these 33 pose landmarks, like all correctly, packed in a dictionary, so that I can. I'm thinking, how can I do this? So I want to have something like, for example, detections. Let's say take nose. So we do detections, nose. That's X and Y, so it's gonna be, it's gonna be a very long. I'm thinking of something, because then you need, something like that. Node X equal this guy. You know what I mean? Detections. But for all the 33, it's gonna be a lot of I want to enumerate that. How can we enumerate that? I'm not sure I can. Is there a way to print the keys of this? If it's not a dictionary, so I'm. Oh, okay. Let's do this. What did I do? So landmark, I think that these nodes and things are just indexes. It seems so. Give me the len of this. Yes, 33. So these are just indexes, which means, hang on, let me think of this. mp holistic dot post landmark nodes. What is it seems to be, if I convert this to integers, it's at 0, right? Yeah. Okay, and if I do this with 0, I get the nodes. Okay, so we can be smart with this, because we can say let's do this. Okay, pose landmarks. It's a dictionary, no? In which we say how do you do column editing with Visual Studio Code? I forgot the Studio Code. Alt Shift. I don't have Alt on my keyboard. What am I doing? Control Shift Alt Arrow. What? Control Shift Alt Arrow. What the fuck are you talking about? Oh, I did it. Boom. Okay. I know it's annoying, even for me. How did I do it? Ah! Is someone still there? Or did you guys fall asleep? Thank you. Thank you, Kudnyami. I was almost falling asleep. Okay, we're done with this. So these are the pose landmarks. So what I want to do now is for each pose landmark, I take the key, I put it as the key in the detections dictionary. I take the value of that key and I use the value as an index. Right? So I do something like this. Instead of taking this, instead of nose, I take index. What did I do in here? Landmarks, pose landmarks, landmark of 0. Yes, okay. So I take the index, and that's gonna be X and Y. So we have to scan pose landmarks. For key in pose landmarks dot keys detections at key. We're gonna clean it up later. Yeah, well. There is also a Z. Oh, and visibility. So now we have all the points. Look at that. We are extracting a ton of, well, a ton, 33 landmarks for each frame. And landmarks are all these post landmarks. Nice. So let's see if it works, because I would take, let's say, nodes. Actually, I would take right left pinky, number 17, and I will try to hide it, and so visibility should be low, and then I will show it and visibility should be high. Okay, let's do that exercise, because when that works, we are good. So here I want to print only left pinky. Where is it? Instead of all that. I don't see shit. $78. It doesn't sound right to me. So oh, it's right. Okay. If I go like this, visibility now is 50, 40, 05, 04. But if I go like this, 0.98, 99. Nice. So I go again, but it's too fast. Let me put a sleep. So I wanna stop the 1 second. I look like an idiot. What am I doing? 80, 08. I don't see. It assumes. Oh, 09, 05, 01. Okay. So even when 095, 098, 020. Yeah, it works. So if my hands are in the frame, even if they are behind, okay, no, they're it's 014. Can you guys see? It's probably too fast, right? Let me see if I can slow this down. How can I slow this down? We can we can it's ugly, but it's just for now, just for okay, you can see then. Nice. So there's no way, there's no reason for me to slow it down, right? Like I want to add a sleep of, let's say, what is millisecond? Oh, these are 250 seconds. Rust. Let's make 0.3. There you go. Okay, it's slowed down. All my pinkies are visible. My left pinky is not. Okay, so that's actually stupid, because 0.70, it's wrong. 0.6. Oh, that is right. It's going down now. Yeah, it's correct, because the frames have been slowed down. So it has to catch up. Yeah, okay. It's going down. It will go down until 0.1 or 0. That's my right one. 0.4. Okay, so it counts by half of the hands. It's a bit weird, because it counts 100% is 1, so now it counts by approximately 50% because of only one hand visible. If I put my last hand invisible, it will go down. And if I put the left pinky up again, it will go up. That's right. That works. I put this hand down and it goes down to 0.2, even less. That's correct. But the right hand, it goes up. The thing is that I think the model is a bit stupid. It doesn't realize that this is the right hand when it's alone. It will realize it's the right hand when it sees it together with the left hand. That's the problem. Okay, by the way, seems to work. Okay, so let's remove that time delay. So I would put these landmarks in settings. Here. Okay, these are the 33 post landmarks. We can call them post landmarks and just import them from here and remove this. And do that. There you go. You can get rid of this and that. Nice. There was another thing I had in mind of doing. Let me see if all works here. Yes. Okay, so we can stop printing this as well. So it should be slightly faster. Oh, very fast. Much faster, wow. Okay. I feel it is much more smoother. Okay, there was another thing. I said I'm gonna do it later, and that was I think this one. No, this one. Yes. So here I want to add the draw equal true, and we'll say if draw yeah, text body pose from main. No, detect SSD object from main. Yeah, draw. Let's be explicit. Returns annotated image, and then we print. Yes, so button detect. That's correct. So you see what I'm doing, right? It's if I set this to false, for some reason I don't want to annotate my images. That's fine. Nice. Yeah, so this is done. All right. So, what is missing actually? Because let's check the README. Here we have object detection, we have face detection, we still don't have face recognition, we have hand gesture, detection, okay, we still need face mesh and face tessellation. Now, these things are not 100% useful for what we need, but they're actually cool because they allow you to create a face mesh, which means you can annotate the face with features. There are like several hundred points, landmarks of your face, and you can train a model to predict, for example, estimate the face, sad, happy, thinking, the face expression. Now, for the sake of a surveillance system, I don't know, I'm not really sure this is useful. It's what you guys think. Like, how can we use an intruder can be faking his like quite happy, and it's not really something you would use to predict that someone is, I don't know, going to steal. It's not from there that you understand. It's not from the face desolation that you understand if someone is a good boy or a bad boy. You probably would detect, you would predict or estimate that a person is stealing something from the body, from the hand gesture, from the body pose, from the position where he is, for the time he or she spends near a particular object, you know, these kind of things. But from the face, I'm not really sure. I'm not really sure. So here we should have this should do the face mesh. I don't know what's useful for this. Don't ask. I have no fucking clue. It's a mesh, so. I would switch it off. We have it. We'll never use it, but we have it. Let's do the face tessellation. Hey Alfred, what's up? Come here. Sometimes I have some baby issues here. Okay, so face tessellation, include drawing dots. That's what I don't like of Python and Python developers. They use like these fucking long names. Ridiculous. Like seriously, how to put me in trouble at 8:30 p.m. Okay, so if we, so in fact, so under results, which is out of the model, we already have these things. We collect all possible landmarks. We just don't draw them. We don't draw them in the frame, but in fact they are calculated. So the model has been trained to predict all these things. Now you want to use these things or not, up to you, but the model predicts them. So the face tessellation, let's see if we activate what happens. Of course, you see, there is this problem. Oh, this is cool. That's the tessellation, you see what I mean? So with these things you can put another face, tessellate that face and patch it on top of mine, or create an avatar. Is it visible? I think the color is not that in contrast. I should have used a fluo green for the tessellation of the face, but yeah. Try to get close as possible. Yeah. And the cool thing is that it really okay, yeah, it works. Of course, if I move my head towards the camera, it loses the, you know, the rotation. It's not really good at keeping the rotation. But yeah, this is not it's not for video games. This is more for much less sophisticated than that, but still pretty good. So yeah. Okay, so let's update this one. Now we have face mesh, face tessellation. We don't have face recognition yet. So we have to add also object tracking. That's another very important thing that we are going to implement definitely next time. And you know, this will help us with improving performance and saving a lot of time computing stuff that we don't need, the object tracking. But I will call it a day for now, and I will do that next time. So what I'm gonna do now is just, you know, putting this stuff on Git. We add the tactilistic. What else did we do? We modified a bit of stuff. So implement holistic face mesh and tessellation. And git push. There you go. It's all there. Also what we need, what we are building, it's all there. And these are all they need to be updated still. Okay. I guess that's it. Folks, whoever is there, it was a nice journey. I hope you had fun. I did. Let me see if I guess that's it. Thank you everyone for following, and I'll speak with you next time, which is Thursday, I guess. But check the schedule on twitch.tv/datascienceathome/schedule. Thank you so much. Bye bye.